The regulation of cellular aging involves a complex interplay between nutrient sensing, oxidative stress, mitochondrial health, and repair mechanisms. Among the most crucial signaling pathways in this regulatory network are mTOR, mechanistic target of rapamycin, and AMPK, AMP-activated protein kinase. These two act as metabolic gatekeepers, determining whether cells grow and proliferate or enter a state of conservation and self-renewal. mTOR promotes anabolic processes and is associated with aging acceleration when overactive, while AMPK senses low energy states and activates protective mechanisms, including autophagy. Interestingly, certain vitamins, especially B3, niacin, and its derivatives, D and C, can influence these pathways in significant and promising ways, offering potential for nutritional strategies that actively modulate the aging process. Vitamin B3, in the form of niacin, nicotinamide, and its more bioavailable derivative nicotinamide riboside, NR, or nicotinamide mononucleotide, NMN, plays a central role in mitochondrial function through its contribution to NAD, nicotinamide adenine dinucleotide, biosynthesis. NAD is not only a key coenzyme in redox reactions, it is also an essential cofactor for sirtuins, enzymes that regulate metabolism, DNA repair, and longevity. Sirtuin activity, in turn, promotes AMPK activation and suppresses mTOR signaling, shifting the cell into a more catabolic, repair-oriented state. As NAD levels decline with age, the energy-sensing capacity of cells weakens, and the balance tilts toward mTOR-driven growth and inflammation rather than renewal. Supplementing with B3 derivatives restores NAD pools, reactivates sirtuins, and indirectly enhances autophagy, offering a powerful tool for slowing age-associated degeneration at the cellular level. Vitamin D, often recognized for its role in calcium homeostasis and bone health, also exerts wide-ranging effects on immune function, inflammation, and cellular aging. Its active form, calcitriol, binds to the vitamin D receptor, VDR, influencing the expression of hundreds of genes. Among its lesser-known but critical roles is its ability to suppress mTOR signaling and support autophagy. Vitamin D helps modulate the cellular response to oxidative stress and inflammation, two hallmarks of aging that drive mTOR overactivation. In immune cells, adequate vitamin D levels correlate with a more youthful, responsive phenotype, one that maintains autophagic function and avoids the senescent, pro-inflammatory state often seen in older adults with deficiency. Moreover, vitamin D indirectly promotes AMPK activity by improving insulin sensitivity and mitochondrial efficiency, particularly in metabolically compromised tissues. Vitamin C, a potent antioxidant and cofactor in collagen synthesis and iron metabolism, may not appear to directly regulate mTOR or AMPK at first glance, but its influence is subtler and no less significant. Ascorbic acid supports the oxidative balance necessary for normal AMPK function. Chronic oxidative stress suppresses AMPK, impairs autophagy, and accelerates the aging of mitochondrial networks. By neutralizing excess reactive oxygen species, ROS, vitamin C maintains the redox environment that allows energy sensors like AMPK to respond properly to nutrient states. Additionally, vitamin C supports mitochondrial biogenesis and function, both of which are essential for healthy aging and autophagy induction. In some studies, vitamin C has also been observed to influence the expression of genes involved in autophagy and cellular repair in stressed or damaged tissues. The interactions between these vitamins and the mTOR/AMPK axis are not isolated. In fact, they appear to reinforce each other in a coordinated way. For example, a combination of NAD precursors like NMN, vitamin D, and vitamin C can collectively lower inflammation, enhance mitochondrial efficiency, suppress inappropriate mTOR activity, and activate autophagy. This combination acts as a molecular reset, guiding cells away from unchecked growth and metabolic rigidity and toward repair, adaptability, and improved stress response. These shifts are especially beneficial in aging tissues, where metabolic flexibility is often lost and chronic low-grade inflammation, inflammaging, disrupts normal repair cycles. More importantly, the influence of these vitamins goes beyond basic nutrient sufficiency. The levels required to modulate these pathways, often referred to as nutritional pharmacology, may be higher than the minimum needed to avoid deficiency, but still well within safe ranges. For instance, Optimizing innate metabolism via B3 derivatives has shown promise in animal and early human studies for improving mitochondrial health, cognitive function, and cardiovascular markers. Similarly, maintaining vitamin D levels at the upper end of the physiological range, typically around 40 to 60 nanograms per milliliter, has been associated with lower rates of age-related disease and better immune resilience. Even vitamin C, when taken in moderate but consistent doses, has shown potential in enhancing endothelial function and reducing oxidative damage in aging vessels. In summary, vitamins B3, D, and C play a vital role in modulating the key nutrient-sensing pathways, mTOR and AMPK, that govern aging and cellular regeneration. Far from being passive dietary components, these vitamins actively shape the internal signaling landscape that determines whether a cell will prioritize growth or repair. Their ability to restore metabolic flexibility, promote autophagy, and support mitochondrial renewal makes them indispensable in the modern anti-aging toolkit. As our understanding of nutrient-gene interactions deepens, these vitamins may come to be recognized not just as essential, but as strategic agents in the quest to extend human health span and cellular youthfulness.